Welcome to this video, dear learners. So in this video, we'll be just explaining a few concepts under circle theorem, okay? Or sometimes they call it circle geometry, okay? But we'll be talking about properties that you need to know under a circle. This question comes in paper 1, okay? Never misses, okay? So what you are seeing here is a circle, okay? And I want you to understand the terminology first. So the total length of a circle, this length, all of it, okay, we call it the circumference, okay. You need to understand because I'll be talking and referring to the circumference throughout the video, okay. So it's called the circumference. Now, this being the circumference, it's the whole length, right? So when I say circumference, just know I'm talking of any point within this whole circle, okay. And then this here is the center of the circle, okay. It's what? The center, okay. That's the center of the circle. And then now we come to other terminologies now. From circumference, let's say at this point A, okay. At this point A, I decide to make a line, okay. I decide to make a line from A going to the circumference, okay, like this. So this is O, where the center is. I decide to make a line like that, okay. So this line that comes from A, which is the circumference, to the center, okay. So it's from A to the center. We call this line, it is called, it's given a name, beautiful name. It's called the radius, and we'll talk about it very much, okay. So it is called the radius, okay. It is called the radius. Now, the other thing is, if you extend this radius further, okay, you extend it further to the other side, okay, extend it further to the other side, maybe to point B, which is here. So here it's more like now you're having a radius and another radius, okay. Now if you have let's say we denote this by a small letter r, also this one small letter r. So now we know that when you add radius plus radius, okay, what you get, we call it what? We call it the diameter, okay. We call it the diameter, okay. So meaning from here, the whole thing now from A to B, and it must always pass through the center. That's why just the emphasis, So this one is called the diameter D, okay, diameter. Now, like I said, it must always pass through the center for it to qualify as a diameter, okay. If it does not, it's not considered diameter, okay. So for it to qualify as the diameter, it must pass through the center, because you can have a line, let's say at point C here to another point D here. You might have a line like this, okay. Now, this line here is not diameter. Why? Because it's not passing through the center. Instead, such a line, we call this one, we call it a chord, okay. It's called a chord, okay. It's called a chord. So this is a line that is coming from circumference to circumference, yet not passing through the center, okay. So these are the terminologies that you need to be aware of, okay. The terminologies that you need to be aware of. So now we are going now straight into the properties, okay. We are now going into properties of a circle, and this is where I want us all to pay attention. The properties of a circle. they are not very, they are not many. Okay, they should be about 7 or something. Okay, they are really not many. Okay, so let's see now. I don't know why I'm losing light. Okay, I think this is better. Okay. Right, so now we are going into now the properties of a circle. Okay, so property number 1 that we'll discuss is called we'll talk about it. It's so we call this one the angle. Okay, the angle on the circumference, the angle on the circumference originating, sorry about that, angle on the circumference originating from the diameter is equal to 90 degrees. Okay, so now what are we saying here? Okay, according to this property, what is it that we are saying? Okay, so what we are saying here, the angle on the circumference, so it must be, that angle must be on the circumference, meaning it must be along this red line, what I labeled as the circumference. Okay, originating from the diameter. So let's have a diameter, and I'm going to draw it not the way I drew this one straight. I'll just make the diameter maybe even like this. We should know that so long as it's passing on the center. So this is the diameter AB. Okay, this is the diameter. So now an angle that will originate, okay, an angle that will originate from AB. So let's say it originates from AB, it goes on the circumference, okay, like this. Okay, it's supposed to be like that. Yeah. Okay, so the angle that is formed here, that's what it's talking about. Okay, the angle that is formed there here is 90 degrees. So you should always remember this being the diameter. It is now the origin for this angle C. Okay, we call it angle C. It is now the origin of the angle CI. Okay, it is the origin for the angle at C. Okay, so even in cases where it originates, so anywhere where it originates, so long as it's coming from diameter, it can even be somewhere there and it goes like this. So long as it's coming from the diameter and it's on the circumference, this still is 90 because its origin is the diameter. This is where it's originating from. Okay, so you have 90 and 90 there. Okay, so this is what this property actually means. Okay, so we're going to say that angle ACB, which is this one, is equal to angle, let's make this one as D, to angle ADB, and these are both equal to what? 90 degrees. Okay, so that is the property that we've talked about. Okay, then we go to property number 2. Property number 2. So number 2 we are going to say that okay, I want you to listen close. We'll talk about the chord. Okay, so here we meant the diameter here. Here the diameter was the origin. Okay, origin here is diameter. Origin was diameter here. So origin must be diameter and the angle must be on the circumference. Okay. Now here, origin is the chord. Again, angle must be on circumference. Okay, angle must be on what? Circumference. Okay, that's what we're saying. So what's the name of this property? Okay, what is the name of this property? So this property, we say that we simply say that use blue ink. So according to this property, we say that all angles on the circumference. Okay, we said the angle must be on the all angles on the circumference okay that originate from the same chord are equal. Okay, all angles on the circumference that originate from the same chord are equal. That is the property here that we are talking about. Okay, so we know what a chord is. It's just a line. Here we say the chord is a line from circumference to circumference, but it doesn't pass through the center. Okay, so let's put a chord maybe here. We illustrate, and this chord will give it a name A, B. Okay. Now, any angle that will originate from this chord, all angles that originate from this chord, and they are on the circumference. This is the key word. They should be on the circumference. Okay, they should be on the circumference. So if we make an angle on the circumference like this, we call it angle C. Okay, and another angle also originates from the same chord, AB. You see, these are all coming from AB. So you should follow them. We make this one D. So you follow its origin. You must follow. So this is the origin. Okay, so we were saying that this is the origin. Okay, this one here is the origin. Okay, and it has raised two angles, this one here and this one here. Okay, now it can also raise another angle. Okay, it's also possible that it can raise another another angle. Okay, it is very much possible that it can also raise another angle. So you can even have three angles so long as they maintain the same origin. Okay, same origin. So this one you can call it angle maybe E. Okay, angle E. So according to the property, and if you follow the property very well, okay, according to the property, all these angles are equal. Okay, angle D. Okay, angle D, angle C, and angle E, they are all equal. Okay, so these angles are equal. So the way we read angles, this one is read as ADB. So we're going to say angle ADB is equal to this one zeroed ACB, ACB, this one is zeroed AEB, AEB. So all these three angles are equal. In other words, if this angle is 20 degrees, also this one must be 20 degrees. Also this one must be 20 degrees. Why? Okay, so why are they equal? We said the origin must be the chord. They must originate from the same chord. So they are all coming from AB. You've noticed this one, AB, this one, AB, this one, AB. They are equal, okay? Even if there were four of them, they will all be what? They will all be equal, okay? They will all be equal. That's the property here. Then now, the other thing now that we want to come to, the other property, okay? The other property, do this. So the other property will be this. We are going to say property number 3. So property number 3 now states that opposite angles in a cyclic, okay, opposite angles in a cyclic what? Quadrilateral. Quadrilateral. So quadrilateral is simply four-sided polygon, and I'll show you that time. Add up to 180. They add up to 180 degrees. Okay, let's see. So let's have a four-sided polygon. Anything you make, so long as it has four sides. So you have a chord here, okay? You have a chord there. Maybe you have another chord there, okay? And another chord here. Oh, this is a cyclic quadrilateral. So long as it has got four sides, right? So, and all the four sides are touching the circumference, okay? So you can say this is A, this is B, this is C, this is D, okay? So all the four sides should be touching the circumference. So now, according to the property, we are saying that opposite angles are equal. Now, what do you mean when you say opposite, okay? Opposite opposite angles are equal. What do we mean by that? Opposite angles are equal. We mean that angles that are facing each other, for example, not they are equal, sorry, they are not equal. We say they add up to 180 degrees. So these that are facing each other. So the angle here at A and the angle here at B, if you add them, okay, it will give you 180. So angle A, you add it to angle B, should always give you 180 degrees. Also, these they are facing each other. So angle, sorry, it's D here, angle A and D. So angle B plus angle C, they also add up to 180 degrees. That's the property, okay? That is the property that this one is talking about. So one thing you should know, it must be a quadrilateral, four sides, okay? And then these four sides, those that face each other, okay? These are facing each other, okay? So these, if you add them, they should give you 180. The same way here, if you add these two are facing each other, if you add them, they should also give you 180, okay? So you must really understand these properties, and they are very simple to understand, okay? They are very, very easy to understand. Let's go to the next property. So property number 4 according to property number 4, this property it has to do with because all these three properties that we've just discussed now, you can even use them and you would solve a number of questions. But this property has to do with the center and the radius. Okay, this one has to do with the center and the radius. So we're going to say this: the angle on the center, is twice the angle on the circumference, provided they originate from the same chord. Okay, the angle on the center is twice the angle on the circumference. Let us show this. Okay, so here we have two triangles, okay, and we're going to come up with a center here and a center there. Okay, now let's do this. I'm going to write them differently, but they are all the same property. Okay, I'm just going to write them a bit different. For the first one, I'll put my radius here. Okay, I'll call this radius AB. Okay, I mean the diameter. Okay, so we know that this will be radius. Now if we come up with another radius at this point, okay, and then here we have a chord. Let's have a chord here. This chord, I'll just say C. So this is a chord, so this is also a radius. Now let's say now this chord also originates an angle that will connect with B there. So like I said, these things are all about visualization. So I'm going to have something like this here. Then here I'm going to have the usual that we always use when teaching this property. So if you have a chord AB and you have two radii like this, a radius and another radius, and this chord again originates an angle on the circumference. Okay, yeah. We call this one C. So the center O, so the center O. Okay, so now what are we saying here? We are saying that, let's go to the property again, the angle on the center. Okay, the angle on the center. So this is the angle on the center. This is the angle on the center. Okay, so if you notice this and this, they're not different. I've just flipped it like this. Okay, and that's what they'll do to confuse you. You still have radius here. You still have radius there. Okay, this and this are not different. I've just flipped it like that to show you something. So the angle on the center is this angle here. We're saying is twice the angle on the circumference, and the angle on the circumference is this one. Okay, so now you notice the one on the center must have radius and radius, radius and radius. Okay, so I say this must be twice this. In other words, if this is 80 degrees, what would be this? Half of that, which is 40. So this must be twice this, meaning if you are given this, multiply by 2 to get this. If you're given this, divide by 2 to get that. Okay, so here Let's say we are given 22 degrees. What will be this? We said this must be twice this. So multiply this by 2. You have 44 degrees. Okay. This property is very simple. You just need to understand it like this. And you should always try to visualize it. Okay. So the angle on the center. So if you haven't understood, please watch the video as many times as possible until you catch it. Okay. We are now going to another property. Okay. After that, we'll do now an example question from a past paper. Okay, so the property number 5, this property states that the angle formed between a radius and a tangent is 90 degrees. The angle formed between a radius and a tangent is 90. It's 90 degrees. Okay, so let's have a look at this. So a tangent, for example, I'll call it tangent AB, and this is the center. So any line drawn from the center of circumference is the radius. So this is the radius. So what we're saying is the angle that is formed. This is the tangent. So a tangent is a line that just touches the surface of a circumference. Just at the surface there, like that. So the angle formed between the radius and the tangent. So this is the radius and the tangent. This angle here. Okay, it's 90 degrees. Similarly, this one here will be 90 degrees. Okay, that's what the property here is saying. Okay, that's what the property here is saying. Now, you might have another tangent, maybe it passes here. Okay, so here you have now two tangents. Okay, here we have two tangents. Of course, this C here. This is another tangent. Okay, this is another tangent. Okay, so you can have this tangent and I'm sure you see sometimes questions like this. So if you have another radius there, like this still applies. So long as the angle is between tangent and radius, meaning this one here is also 90. This one there is also 90 degrees. Okay, so long as it's a tangent and the radius. Okay, as a tangent and a radius. So now you have an angle that will be formed between these two radii. Okay, now this angle, you notice that it is opposite to this one here. Okay, these are opposite angles. You can look at them like that. They are opposite angles. So now why am I talking about this? This is because when you add the angle here, let's say the angle here, we call it B, sorry, not B, let's use a different, say P. Let's say if you add the angle here called P and the angle here called Q, so angle P plus angle Q should give us 108. Okay, that's the property here. Okay, so we've stretched out two properties at a go here. Okay, we have a tangent, the radius, the angles formed here, 90. Okay, but they won't be very much obvious in here, and you'll see when we do a question. Now, these properties, they're not usually obviously seen. Okay, so let's go to the last property, the 60th one. Okay, here I've combined two properties. So in total, there's supposed to be 7. So according to this property, simply says the exterior angle is equal to the opposite interior angle Okay, so let me just show you what we mean here. Okay, so here we have something. Let's say we have A, B, C, okay, and we have P, O, Q. Okay, let's put Q here. So what we mean, the exterior angle. So this is the triangle. Okay, this one is the triangle. So if it's a triangle, all the angles inside the triangle, this one, and this one, all these we call them interior angles. Call them interior angles. So we're saying the exterior angles now. These are angles that are outside. Outside the what? The triangle. Okay. Outside the triangle. Exterior meaning will be this angle here is an exterior, and the angle there is an exterior angle. Okay. So you have P here. So angle PCA is exterior. This one is exterior. Also, this one is exterior. Okay, but these three are all interior angles. So we're saying the exterior angle is equal to the opposite interior angle. So this exterior angle, we're saying it is equal to the opposite interior angle. So meaning this one will be equal to these two. You add them. Okay, I want you to understand nicely this one. This angle here, I'll call it angle X here, is equal to the sum of these two. I'll call this one Y, I'll call this one Z. Okay, so the angle there X is equal to the sum of Y and Z. That's the property here, what we're saying. Okay, similarly again, this one will be equal to the sum of that. Okay, same thing, X will be equal to Y plus Z. Okay, so the angle that is outside is equal to the sum of these. Okay, that is the rule. So now before we end these, we just need to discuss a property here and angles. Here when you have a triangle, okay, and it's very important, don't miss this one, okay. When you have a triangle anywhere, you should know that when you add all the three angles, they should add up to 180, okay. Also, the other thing is that if a triangle has got these lines here, we call it an isosceles triangle. And according to this property, if it has these three lines, these two lines, it means that this angle here and this angle here are equal. Okay, these two angles. So we say base angles are equal. The base angles are what? Are equal. Okay. Let's have an example now. I think we've looked at quite a number of properties. Let's do an example. So we have this question. You can see there the question on the other page. The question is from 2022 GCE. Question 17. In the following diagram, A, B, C, and D are points. Okay, A, B, C, and D are points. And you can see this is a cyclic quadrilateral, right? Okay. Then you also told they have a center. Okay, so if this is a center, automatically you know this is radius, this is radius. Okay, so this is a center, and automatically you know this is diameter BD. Okay, and they've said BD is diameter. AD and AC are equal. AD and AC are equal. Now remember, so this one here, triangle, the triangle there, A, okay, C, D is an isosceles. Remember what we said, an isosceles, the base angles are equal. So they are just letting you know some things, okay? So the first question here, follow it nicely and understand. Find BAC, okay? And A says find BAC. BAC. So we're finding this one here. So now this one I want you now to remember all the properties we've done, okay? And you should know that BAC, what is the origin? That's the first thing you ask. Where is it originating from? You follow its parents, it's originating from B and it's originating from C. Then you ask yourself again, is there any angle originating from BC? You have this angle originating from BC, and there a property, you've already seen it. This and this will be equal. Angles originating from the same chord, okay? So you're going to say BAC is equal to BDC, which is what? 22 degrees. And then you're also going to say now that the property here that you are using is that say angles, okay, BAC and BDC, okay, originate on the same chord BC. This is the chord we're originating. And the other thing you can see, they are all on the circumference, okay? They are all on the circumference. You've answered the question. Very easy when you've understood the properties. You don't need to even stress thinking so much. So we go to question B. Find CBD. So what is CBD? CBD. CBD is this one here. This will cause a bit of stress, but we can find it so long as we just apply the properties. Okay, it's quite tricky, this one. I've seen it. Okay, so now let's do this. Now we're finding CBD, this one here. Okay, so now for us to find this, what will happen is we need to think of properties that we can use. Okay, now look at, guys, the whole length from here to here, BO, this is a radius again. Okay, also this is a radius, we've already said that. So now you have two radiuses, okay, you have two radiuses, meaning this angle here and this one, they are both equal. Okay, I hope you see this. Okay, so what I'm saying is this: when you get this side and this side, okay, remember you have B and C here. Now what I'm saying, since this is the center O, okay, I've just gotten this part. This is the center O. This will be radius. This also will be what? Radius. Okay? This also will be radius. Now remember, you also have, when you extend this here, this side, there is D here, and then these two are joining like this. Okay, and here all I'm trying to show you is that if this is 22, these are radius, this is also 22. Okay, this here is also 22, and if this is 22, I hope you get this. I hope you get this. This is 22, this is 22. So you can easily find this one here. When you get this triangle, all angles should add up to 108. So 22 plus 22, that will be 44. Okay, and you subtract now. You can say, okay, 180 minus 44. What do we get here? 10 minus 4, that is 6. Yes, 7 minus that is 3. So 136. So this one here inside is 136. Now this is 136. You can find the one this side. Okay, you can find the one this side. This is a straight line. So this one here will simply be 44. Now why am I saying this one is 44? Okay, again, if you follow the property, angle on the circumference is twice the angle on the center. So 22 times 44, 22 by 2, you get 44 still, right? Okay, here you have This is the angle on the center, this one here. And this is the angle on the circumference. Here it's 22. What did we say according to our property? We said according to the property, this is twice this, so it's 44. So still proves this is 44. Okay, this is 44 here. Now this is a radius, these two angles are equal. Okay, so we can just say, okay, this angle here, I put x just for the sake of easy. So now we are going to get BOC, okay, BOC. These are all radiuses, so these are equal. So x and x. Now, if you add all the angles inside, they should give you 108. Yeah? Okay. So you are going to say CBD here. How are we going to calculate? So CBD will be equal to what? CBD. What we are going to say, we're going to add x and x. So we're going to say x plus 44 should give us 180. X plus x, that will be 2x plus what? 44 is equal to 180. Take 44 this side, 2x is equal to 180 minus 44. So 2x will be equal to 180 minus 44. Let me just subtract like this. 10, that is 6, get 136. So 2x, okay, is equal to 136. Divide by 2, divide by 2. So here you get what? 68 degrees. So therefore, this angle is 68 what? Degrees, okay. 68 degrees. And lastly, we are being told to find the ACO, okay. ACO. So what will be ACO? So ACO is this. Now remember here we said this is 68. This must also be 68, okay. So here I'm just going to get BDC so that I illustrate something for you. B, and then you have D, and it's something like this, okay. This one we're told it's the diameter with the center O here, which goes like this. So far, what we have, you also have another one which is going up like this, going to A. So the angle that we are finding is this one here, okay, which is ACO. ACO. This is what we're finding, okay. So I've just gotten this part here so that I can show. So you have this angle which is here, okay, 22. This angle is 22 degrees. See, this one we said is 68. This one also is 68 because this whole thing is 68. 68. Now, as we're just interested in this particular thing here, okay, just this particular thing, okay, which is ACO, okay. So now to find ACO, what we'll do is this. We are going to find, remember this one goes like this, and here we have these two things. So the whole length, this one and this one, they add up to, they are equal, okay? This is an isosceles. So this one and this one also originating from BD. So this means this is also 68. Okay, so you can find for this, okay? So you're going to say 68 plus this whole thing, we call it just C, plus D should give you 180. So 68. Now these are equal, so you can just put, if this is x, this is 2x is equal to 180, okay. So 68 plus 2x is equal to 180. So 2x is equal to 180 minus 68. And what do we get? Okay, 180 minus 68, 2, we get 112 over 2, x will be equal to 56. So now, what we're saying now is that these two angles, this one and this one, they are 56. Now we are looking for this particular one here, ACO. So we have a 22. So we just say 56 minus 22. We get 4, and the angle is 34. So this angle is 34 degrees, okay. So here we've used quite a number of properties, and you can go through the video as much as possible so that you can just understand these things. Okay, otherwise they are not that difficult. Just practice them more and more. Okay, this is where the video ends. Please, hope you've learned something. Like and subscribe, share the video. And the other thing is, we are starting our tuitions for 2025. Those that would like to be part of us, you can leave your number in the comment section or contact me on my number on the WhatsApp channel, and I'll get to you. Those that are interested in 2025 online tuitions.